Yes, students, is there any doubt in this key concept? Hmm? These are the most important concept. That is the keys, why key needed, then the primary key, candidate key, super key, as well as the foreign key. So, is there any doubt? Let me know here only. At least reply, yes, ma'am. We can proceed then.
No, ma'am.
Okay, move to the next slide. That is the schema diagrams. Yes, we already know the concept of now schema. Schema is the overall design of the database. We already covered that topic, that is the ER diagram, how to convert ER diagram into the database schema. Just after learning the key concept, how it will show into the schema diagram, let's see. See, a database schema along with a primary key and a foreign key dependencies can be depicted by a schema diagrams. We already know. Yes. Have you all remember how to convert the ER diagram into the database schema? We learn this concept in a unit 1. Okay. Entities converted into the tables. Attributes are the columns in the tables. Then whenever there is a relationship, show that relationship. Hope so you all remember we took the example of the company. Or may I open the slide that we saw the three steps in that. First one is the create entity table, adds these attributes, and then uh, associate the relationship in these tables. Have you remembered? Yes,
Yes,
no,
ma'am.
yes. Then we can move forward further. Over here, see schema diagram. Now, just we are looking into concept how to show the primary key, foreign key in that schema diagrams. At that time, we are not aware about the key concept. Okay, a database schema along with the primary key and the foreign key dependencies can be depicted by a schema diagrams. Okay, figure shows the schema diagram for our university organizations. See over here. Just I enlarge the screen. This is the schema diagram for university database. Okay. So over here, different kinds of tables are present. Which are those? Student table, course, department, advisor, instructor. Hmm? Okay, takes, time slot, teaches, classroom, section. All these are the tables which are or relations in technical word relations which are appears in a box. Okay, so with its name at the top of in a blue. Okay. As well as the attributes are also listed inside the box. For a student, it's a relation name with its attributes ID, name, department name, and total credits. As well as the department is the relation name with its attribute department name, building, as well as the budget. Now, if you observe all these relations very carefully, then in a student, ID is underlined. In a department table or relation, department name is added, underlined. Okay. In instructor ID, just underline. And in a course ID is underlined. What it means? It shows the primary key for that table. Okay. Primary key attributes are shown underline. Okay. Please note down these points. So over here, foreign key also present over here. Because of that, we are showing the arrows. Okay. See over here, ID is the primary key for a student table. Concentrate on a diagram in that student relation. ID is the primary key for a student relation. And here in a text table, left hand side, ID is also attribute is present. That means primary key of student table works as a foreign key in a text relation. Okay. Because of that, foreign key dependency appears as an arrow from a foreign key attributes of a reference relation to the primary key of the referenced relation. See over here, here student ID, in that it works as a primary key. And we are referring to it in a text table, TAKES. So a student relation is a reference relation and the text relation is the reference relations. We are taking reference from student to the text table. Okay. So ID is a primary key in a student table and ID in a text table work as a foreign key. Are you getting, students? Yes. Gauri, it's too late. Okay. Please join on time. What are the points we have just discussed just now? Okay. Are you clear with the concept? How to show the primary key? How to show the reference or a foreign key? Is that clear?
Yes, ma'am.
Is there any doubt? See, if there is a relation, we are showing that relation through an arrow. Okay. If the primary key of one table is reference to the another table, then it works as a foreign key. Okay. So whatever is the strong entity in that primary key is only with yeah, unique one, that is the student, department, course, instructor, huh? And after that these primary key works as a foreign key to the another tables. Okay, in that section, course ID, section ID, semester, like that. Okay. Then In text, the ID, course ID, section ID, semester, these are the foreign key because these are the referred from the another table. Okay, this is all about the schema diagram. Okay, draw this diagram, otherwise take a screenshot, note down these points. First of all, note down these points. Each relation as a box. Primary key attributes are shown in underline format. Then foreign key dependencies appear as an arrow from the foreign key attributes of a referencing relation to the primary key of the reference relation. Like that, just note down these points. Take a screenshot of this schema diagram. Now move to the next point. Relational query language. Relational query language. Just note down the point, that is the relational query language. Up till now, what we have seen, that what do you mean by database, purpose of the database, then the keys, as well as the ER diagram, all these points, as well as the different kinds of languages, that is the DDL, DML, TCL, like that. Huh? All these are the points we have covered. How to create a database, just we create a table with its attributes. Okay, but now the main purpose of the database is what? To access, to manipulate that database according to the user requirement. In the user requirement, we have to manipulate that data. It may be we have to update the data after creation of the tables. We have to update, huh? Inserting the new records. huh? Sometimes whatever is the history or previous, which is no use of the data, then we have to delete that record. So all these manipulation we have to perform. Then how to perform this? So there is a query language for the relational database management system. There is a query language for the relational database management system. Is that clear? Why it's required? To perform different kinds of operations, manipulations, we require the relational query language. Okay? For the communication purpose, interaction purpose with the database. The relational query language use relational algebra to break the user request and instruct the DBMS to execute the request. Okay, you already know the algebra. hmm? In mathematics, we perform different kinds of operations, like there are one operator is present as well as the operands, and we perform some operation on that, and we will get the some result. Like that, it's also a one kind of relational algebra. In that, operators are also available as well as the operands over here. Operands are nothing but the tables. Okay, have you clear with the concept of the operator and operand? First of all, if I say a plus b, If I say A plus B, which are the operator or which are the operands? Let me know. A plus B, just simple. Yes, anyone? Let me know just operator and operand concept. A plus B. Which one is the operator and which one are the operands? No one? Yes, please. It's very simple concept.
Plus is a operator, A and B are operand.
Yes, correct. Very nice, Aboli. Yes, plus is the operator. The plus, minus, multiplication, division. These are the operators. Hmm? And in on which we are performing the operations like A and B. Hmm? A plus B. We are performing the operation A on A and B. Then these are the operands. Okay, is that clear? Like that, relational query language are the relational algebra. In that, operators as well as the operands are present. Over here different kinds of operators present, and operands are over here nothing but the tables, because we are performing operation on the tables, relations. So relational algebra is language which breaks the user request and instruct the DBMS to execute that request. It is the language by which user communicate with the database. Okay, for communication purpose, to extract some info from the database, we are using this language. This relational query language can be a procedural or non-procedural. There are two categories of these language, that is the procedural as well as the non-procedural. Just note down the important points. Okay, now come to the next point. Is that over? Relational query language uses relational algebra to break the user request and instruct the DBMS to execute the request. Query language can be a procedure or non-procedures. Let's see procedural first. Procedural query language. Query is nothing but we are asking something, to the database by applying the systematic way. We are applying, asking something. If you want some info from the database, we have to put the query first, in a query language, in a specific language. It's called a query language. Okay. A procedural query language will have a set of queries instructing the DBMS to perform various transactions in the sequence to meet user request. I will repeat. See, there is a process. That's why it's called as a procedural query language. There is a some process, we have to follow that process stepwise. That's why it's called as a procedural query language. Okay, it will Procedural query language will have a set of queries. It is a single query or we are combining the set of queries. Yes, it's up to you. Okay. To instructing the DBMS to perform various transactions in the sequence to meet the user request. To perform different kind of transaction, insertion, deletion, updations, this kind of transactions. Okay. For example, सपोज तुम्हाला छोटा बहीण भाऊ आहेत, आणि तुम्ही त्यांना सांगताय मला की चहा बनव, तर कसं सांगचाल? आणि ते ही ऑर शी इज नॉट दॅट मच मॅच्युअर, तेवढी मॅच्युअर नाहीये, तर तुम्ही काय करसाल की मला चहा बनव म्हटलं माझ्यासाठी, तर तुम्ही कसं सांगाल? एक कप दूध घे, थोडस पाणी मिक्स कर, किंवा आणखी त्यात 1 or 2 tablespoon sugar ऍड कर, अँड एज वेल एज द चहा चाय पत्ती. इन दॅट वे तुम्ही स्टेप वाईज तुम्ही सांगाल की पहिला म्हणतं की मला चहा बनव 1 कप, ही झाली तुमची स्टेटमेंट. व्हॉट यू रिक्वायर्ड. तुम्ही काय सांगताय की मला चहा बनव, हे तुम्ही त्याला सांगताय, म्हणजे तुम्ही व्हॉट यू रिक्वायर्ड हे पण सांगताय आणि कसं बनवायचं हेही सांगताय त्याला, राईट? सो लाईक दॅट प्रोसिजरल क्वेरी लँग्वेज मध्ये तुम्हाला काय पाहिजे आणि कसं पाहिजे या दोन्ही गोष्टी सांगाव्या लागतात. समजते का? मी थोडं सिम्पल वे करायचा प्रयत्न करते, होप सो तुम्हाला समजत असेल की इन अ. आणि टेक्निकली तुम्हाला सांगायचं झालं, आता टेक्निकली एक्झाम्पल घेऊयात की तुम्हाला तुमचं सीजीपीए काढायचे, पर्सेंटेज काढायचे. फॉर एक्झाम्पल, गेट सीजीपीए प्रोसिजर विल हॅव अ व्हेरियस क्वेरीज टू गेट द मार्क्स ऑफ अ स्टुडंट इन each सब्जेक्ट. Okay, you have to find out the CGPA of each and every student from the marks of the student for each subject. So how to calculate? First of all, you have to calculate the total marks, then they decide the CGPA based on the his total marks. This is the steps we have to follow, the step to get CGPA of in a in a student table. Like that, this procedural query language tells the database what is required. What do you want now? Get CGPA. You want CGPA from the database, and how to get that from the database. How to get? First of all, you have to calculate the total mass, and according to the total mass, you have to apply the CGPA formula on the total marks. So this is the procedural query language, and relational algebra is the procedural query language. Is that clear, students? Yes. You got the concept of the procedural query language.
Yes, ma'am.
Okay. Thanks for the response, Vaishnavi. So relational algebra is the procedural query language, in that what is required and how to get them, the both process you want to tell to the database. Okay. So next one is the non-procedural query language. It's a next type is the query relational query language. In that, next one is the non-procedural query language. Now, as the name suggests, just you have to tell what you required. There is a no need of to tell how to get that info. Hmm? Non-procedural queries will have a single query on one or more tables to get result from the database. For example, get the name and address of the student with a particular ID will have a single query on the student table. Okay. Now over here there is a single query at a time, and relational calculus is a non-procedural language which inform that what to do with the tables but doesn't inform how to accomplish. आता तुम्हाला म्हणजे जस्ट एक फाईन म्हणून आपण तोच एक्झाम्पल रिपीट करू चहाचं. जर तुम्हाला सांगितलं चहा बनवायला, तो तर होपसो सगळ्यांना येत असेल. तुम्हाला सांगव नाही लागत की कसा बनवायचा आहे. जस्ट कोणी तुम्हाला सांगितलं, रिक्वेस्ट केली की बाबा मला माझ्यासाठी चहा बनव, तर तुम्ही लगेच बनवून द्यायचा ना तुमच्या पॅरेंट्ससाठी, लाईक दॅट. It is a non-procedural language which informs that what to do with the tables but doesn't inform how to accomplish this. This query language basically will have the queries on the tables in the database. Okay, is that clear, students? Yes, are you getting, students? And see over here, the relational algebra. This is the example of the procedural query language, and relational calculus. दिस इज द एक्झाम्पल ऑफ नॉन प्रोसिजरल क्वेरी लँग्वेज. ते काय आहे हे आपण आता बघणारच आहोत. ओके, जस्ट नोट डाऊन दीज पॉइंट्स. ओव्हर. So let's see the first, that is the relational algebra. As the we discussed, the relational query language is a relational algebra. Algebra is related to the mathematical concept. That means it's also consists of the number of operators as well as the we are performing the operations on the operands. Okay, relational algebra is a procedural query language which take instance of a relation. See, now here we are taking the instance of the relation as the input. Huh? Instance, we saw the concept of the schema as well as the instance. Whenever we are performing the operation on a specific table, so at that time the snapshot of that relation, current status of the that relation, that table is nothing but the instance. So relational algebra is a procedural query language which take instance of a relation as input. Normally, just instance of the relation is nothing but the table and yields the instances of the relation as the output. We are performing the operation on a table. That's why we are taking tables as the input only. One, it may be a one, it may be a two. One or two tables only at a time. Performing operation on that table, and again we will get the tables or instance of the relation as a output. Inputs also one or two tables and outputs also a table itself. Is that clear? Yes, we are on the concept of the relational algebra. Okay, like a mathematical model, it uses operators as well as the operands, that is the tables, to perform the queries. So an operator can be a unary operator or a binary operator. Are you clear with the concept of the unary as well as the binary operators? Hope so. It was in the concept in a C language, C++ language. different kinds of operators, in that unary operator, binary operators. Yes, ternary operators also present, but over here we will see the concept of only unary as well as the binary. Yes, are you aware of the concept of the unary as well as the binary operator?
Yes, ma'am.
Everyone?
Yes, ma'am.
Okay. Now, who will tell me about the unary operators? If you know, just tell me. मॅम येस म्हटलं की लगेच तुम्ही क्वेश्चन विचारता. नाही, आपण इथं शिकायलाच आलेलो आहोत. हं? चुकलं तर इथं
Which
चुकू. सॉरी.
which is a single operand?
Yes. In unary, we are using the single operand. We are performing the operation on a single operand only. Okay. Suppose in C language plus plus A. That means we are incrementing the value of A by 1. Only one operand is there while performing the operation. That's why plus plus is the unary, as well as the binary. If suppose there are two operands are available while performing the operation, that is called the binary operations. Okay, because there is two operands are present. Okay, so operators can be a unary operator or binary operator. They accept the relation as their input. Okay, here table is a relations as their input and yields a relation as their outputs. Input is also relations. After operations, whatever we will get, that is also a relation, that is also a table. The relational algebra is performed recursively on a relation, and intermediate the result are also considered as a relation only. Okay, but one more thing in that is, while we are giving input as a relation, they have the relation name. Note down this point, they have their relation name. That is, the table name is already provided, but while we will get table as a output, at that time whatever is the table, it has no name. We have to explicitly give the name to that. Okay, so fundamental operations on the relational algebra as the select, project, union, set difference, Cartesian product, as well as the rename. Just note down the relational algebra as well as the why it's required, the different kinds of operations of the relational algebra. And see over here, relational algebra is the theoretical model. Hmm? Relational algebra is the theoretical model to understand the SQL after that. Hmm? For understanding purpose, this is the theoretical model. Is that clear? Okay, today we will stop over here only.